Yeah. All right, guys. So before we get started, are there any questions over any of the assignments thus far? So 663, we are continuing with solving. And these solving problems, and what we're looking at today is very similar to what we did Thursday. We have logarithmic expressions, and we have a number that is not inside the log. Now, for us to be able to solve these, I need one expression on either side. I need one expression on either side of this equal sign. And unfortunately, at this point, the left-hand side has two logarithmic expressions. Guys, we need to be able to write this as a single log. Now, according to the product property, log base b of n times n is equal to log base b of m plus log base b of n. If I had two things being multiplied together inside of a log, I can rewrite it as a sum of those logs. Not too helpful for us here, but the converse. If I have two logarithms with the same base being added together, I can rewrite it as a single log with what was inside both of those logarithms being multiplied together. So on the left-hand side, we do have log of 2x, and we have log of x minus 5. And since their bases are the same, we can rewrite it as log of 2x times x minus 5. Since I have two logs with the same base being added together, we can rewrite it as a single log with what's inside being multiplied together. So being able to do this now gives us one term on either side. We can actually solve it exactly as we were solving on Thursday. Questions on this so far? Now the next step, our second step, was to get the variable out of the logarithm, get it out. So since we're using a logarithm or starting with logarithms, we're going to put both sides to the base of the log. Now because the log does not have a base written, it is understood to be 10. Which means we're going to put both sides to the base of 10. All right, guys. So the left-hand side is going to be 10 to the log base 10 of 2x times x minus 5. And the right-hand side is going to be 10 to the second power. Now our left-hand side, this 10 to the log base 10 is going to simplify, leaving us with 2x times x minus 5. We're just left with what's inside the log. On the right-hand side, we have 10 squared. So putting both sides to the base of 10 got us to 2x times x minus 5 is equal to 10 squared. All right, guys. Questions on anything we've done so far? Now, to start solving, we can't just set this 2x equal to 10 squared, x minus 5 equals 10 squared, because our product property only works if it's equal to 0, our zero product property. So the next thing we're going to have to do is actually distribute this out. 2x times x is 2x squared. 2x times negative 5, 2 times negative 5 would be negative 10. We still have that x is equal to 10 squared, 10 times 10, which is 100. So we have 2x squared minus 10x equals 100. Now for this one here, we do have an x squared term. So when we start solving it, we're going to either need to get it equal to 0 or get the x squared term by itself. Now I would get the x squared term by itself if we did not have a middle term, an x term. Since we do, it means we need to get this equation equal to 0. So we're going to subtract 100 from both sides, telling us that 2x squared minus 10x minus 100 is equal to 0. Questions on this here? All right, guys. Questions on any of this so far? Now at this point here, we can go about factoring it, graphing, completing the square quadratic formula. But even if we do have to use the quadratic formula or completing the square, there is a greatest common factor of 2. 2 goes in all 3 terms. So we could actually factor it out. Because if we factor 2 out of 2x squared, we're left with x squared. If we factor the 2 out of 10x, we're left with 5x. And if we factor the 2 out of 100, we get 50. So really we have 2 times x squared minus 5x minus 50. Now from here we can actually factor this because this quadratic equation is indeed factorable. So we'll have our 2 sets of parentheses with 3 spaces. Now we're going to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. Bless you. Bless you. If that third term is negative, the signs are opposite. Since 50, our third term is negative, our signs are opposite. One's going to be plus, one is going to be minus. Now we need to find the factors of the first term. Well, our first term is x squared, and its only factors are x and x. Factors of the third term. Factors of 50 are 1 and 50, 2 and 25. 3 is not a factor of 50, neither is 4. But we do have 5 and 10. 6 is not a factor because 2 and 3 would have to be. 7 is not a factor. Well, 7 times 7 is 49. It's too close to 50. And really, that's it. These are the only factors that we have. Now, at this point here, I would use or try 5 and 10 first. And if we check this here to make sure this works, 5 times negative 10 would be negative, or x times negative 10 would be negative 10x. 5 times x would be positive 5x. And negative 10x plus 5x would indeed be negative 5x. That is the middle term we wanted. And again, we don't check every product. We don't multiply it all the way out because x times x is x squared. Definition of factors. Don't have to check yet. 5 times negative 10 is still negative 50. Factors of 50. Questions on this here before we move on to the last set of steps? Now, the whole reason we got it to this form, 2 times x plus 5 times x minus 10, is zero product property. The only way I can multiply 2 or more things together and get 0 is if one of these expressions, one of the terms, is indeed 0. So the only way I can multiply these things together, these terms together, is if either x plus 5 or x minus 10 is 0. 2 doesn't make a whole lot of difference. I cannot make this 2 be 0. There is no variable input for it. Now x plus 5, I can solve it by subtracting 5 from both sides. That does give me x by itself and tells me x is equal to negative 5. We can do the same thing with x minus 10, but this time we're going to add 10 to both sides, telling us x is equal to 10. So if x is equal to negative 5 or x is equal to 10, those are our 2 values of x that would make that quadratic equation be 0. Questions on this here? Now with logarithmics, we do need to check. Exponentials, we can put anything we want in an exponent. We can put positive numbers, negative numbers, rational, irrational. We can put any type of number in an exponent. Logarithms, I cannot take the log of a negative or 0. What's inside the parentheses with the log cannot be negative or 0. Now that doesn't mean that x cannot be negative. Because on Thursday, we definitely had a few cases where x was negative, came out to be a positive number, still worked. But here, If we look at negative 10, I don't think it was negative 10, negative 5. If we check it first, this should be 2. Log of 2 times negative 5 plus log of negative 5 minus 5 is supposed to be 2. Now, as we work this out, 2 times negative 5 is negative 10. Negative 5 minus 5 is also negative 10. So we have log of negative 10 plus log of negative 10. Log of negative 10 does not work. We cannot take a log of a negative number. So this doesn't work. Negative 10 is thrown out. Not so much because x equals negative 10, but because when we plug it into the original problem, in those two spots, we get log of a negative. So negative 5 is thrown out. It's an extraneous solution. Now I can do the exact same thing. I'm just going to erase instead of rewriting the whole thing. Because I can also check when x is positive 10. Now in the first one, 2 times 10 gives us 20, so we have log of 20. And the second one, 10 minus 5 is 5. So we're looking at log of 20 plus log of 5. Log of 20 plus log of 5 is 2, which is what we wanted it to equal. So really when we're checking, we're not so much checking to make sure both sides are equal. We're trying to make sure what we have inside the logarithms before we start simplifying or evaluating them, we do not have negative or 0. Because any value of x that would make the expressions inside the logarithms be 0 or negative does not work. Not so much the value of x is negative or 0, if it makes that expression be negative or 0. Questions on this here? Let's look at the next one. Log base 6 of 6x plus log base 6 of x minus 1 is equal to 2. Since we do have two logs with the same base being added together, we can rewrite this as a single log, log base 6 of what's inside being multiplied together. So our log base 6 of 6x plus log base 6 of x minus 1 can be rewritten as log base 6 of 6x times x minus 1. Now to get that variable out of the logarithm, we're going to put both sides to the base of what? Well, what's the base of the log? 6. So both sides are going to be put to the base of 6, because our log 6 to the log base 6 is going to cancel because the base and the base of the logarithm are the same. And what that leaves us with is 6x times x minus 1 is equal to 6 squared. Questions on this here? Multiply through 6x times x, 6x squared. 6x times negative 1, negative 6x. And 6 squared is 36. Now at this point here, we do have quadratic terms, middle term, so we need to get this equation equal to 0. Subtract 36 from both sides, telling us that 6x squared minus 6x minus 36 is equal to 0. Questions on any of this here? Interestingly enough, there is a greatest common factor of 6, yes? Did the greatest common factor of 2 have any impact on the solution? Well, no, it didn't impact anything. Because here, really, we factored the 2 out and then just said, okay, cool. I don't care about it. I just want to see what's going to make it be 0, yes? So couldn't I come in here and just have divided everything by 2 and removed it? Looks like I can. Which means there's a good chance we can come here and divide everything by 6. And if we do this, 6x squared divided by 6 is x squared. Negative 6x divided by 6 would be negative x. Negative 36 divided by 6 would be negative 6. And 0 divided by 6 is 0. Now, graphically, I already have this typed in from earlier today, 6x squared minus 6x minus 36. And x squared minus x minus 6 are 2 equations we have, yes? 99% of this graph, and I don't think that's percentage is accurate, but pretty much almost the entire graphs are going to be completely different, except for 2 points. And those 2 points are where it crosses the x-axis. And since we're solving, I don't care about any other part of the graph except the values of x that are going to make this function equal. And because x squared minus x minus 6 has the exact same zeros as 6x squared minus 6x minus 36, we can get rid of it. Funny enough, the graphing calculator tells us that the 2 values that we're looking for are negative 2 and 3. So if that common factor is just a number, a scalar, we can divide it out, we can get rid of it. We cannot divide variables. Because for each variable that we divide out of the equation, it is one solution we are removing. We're reducing it, we're removing a solution from the equation. Now, if x is in common with all of them, most likely we're just removing an x equals 0 from the equation. Graphing calculator told me the 2 values of x that make this be 0 are negative 2 and 3. Which one do we think doesn't work? The negative 2. And the reason I would lean that way is 6 times negative 2, there's nothing there to correct that negative and make it positive. And if I wanted to check, log base 6 of 6 times negative 2 plus log base 6 of negative 2 minus 1 . Well, as I simplify that first log, I'd get log base 6 of 6 times negative 2 would be log base 6 of negative 12. Realistically, I can stop there because that's as simplified as that gets. I have a negative inside the log. I cannot take logarithmics of negative numbers, so we throw it out, we're done. Even if I kept going, plus I get log base 6 of negative 3. I can't take that one either. We're done. Now the question is, why did it work to begin with? It's our product property. If I have log bases, if I have 2 logs with the same base being added together, we can write it as a product. Negative 12 times negative 3 is positive 36. But I can only use that if we can actually evaluate the logarithms to begin with. I can't. So that means that one doesn't work. It has to be 3. Because log base 6 of 6 times 3, bless you, times log base 6 of, it's 3 minus 1, yes, is equal to 2. Now at this point here, we can go on and see that we have log base 6 of 18 plus log base 6 of 2. We want it to equal 2. Now if I want to, log base 6 of 18 plus log base 6 of 2. We can type it into the graphing calculator. It does tell us it is indeed 2. Apparently, we can use the product property here because what's inside both of the logs is positive. 18 times 2 is 36. 6 to what power is 36? That is indeed. Questions on this here? Hopefully you notice it's not a big stretch from what we did Thursday. We're going to do 2 more with addition. I'm going to have y'all pick 7 or 8. Which one do y'all want to do? Problem number 7 or problem number 8? 8. Log base 4 of x plus 12 plus log base 4 of x equals 3. Again, we do have 2 logs with the same base being added, so we can rewrite this as 1 log with what's inside being multiplied together. And yes, if I wanted to, I could have rewrote this as x times x plus 12. We could have flipped those two. Because multiplication is closed, we can multiply any 2 things in any order. Now, because we do have 1 term on either side, to get the variables out of that logarithm, we need to put both sides to the base of what? The base do we need to apply? 4, because the base of the logarithm is 4. 4 to the log base 4 will cancel. Now I'm going to flip that around just so we have it. I like it better having that monomial term, that single x out front, not after. We could have left it as x plus 12 times x, would have given us the exact same thing. Questions on how we got to x times x plus 12 equals 4 to the 3rd. On the left-hand side, we're going to multiply. X times x is x squared. X times 12 is plus 12x equals 4 to the 3rd is not going to give us an irrational number, a really nasty decimal. But the question is it going to be a number that's not too big? Well, 4 to the 3rd is 64. That, for the most part, is a nice number. Now we need to start solving. We do have a middle term. We do have an x and an x squared, so we do need to get this equation equal to 0. So we're going to subtract 64 from both sides. So we have x squared plus 12x minus 64 is equal to 0. Now at this point here, we don't have an a value. There is no greatest common factor. So we can actually graph it or factor it. So we can graph it like we did the last one, or we can factor. Since the 3rd term is negative, our signs are indeed opposite. Now we need to find the factors of the 1st and 3rd term. Well, our factors of x squared are x and x. Now factors of 64. We have 1 and 64, 2 and 32. 3 is not a factor, but we do have 4 and 16. 5 is not a factor because it doesn't end in 0 or 5. 6 is not a factor because both 2 and 3 would have to be factors. 7 is not a factor. My main reasoning is 7 times 9 is 63. 63 is too close to 64 for 7 to work. 8 and 8. Now, if I was picking numbers to try, 8 and 8 would not be on the list. Because since we have opposite signs, numbers in front of x are the same, that would actually give us a difference of perfect squares. Middle term would be 0. So I'd go to 4 and 16. 16 minus 4 is indeed 12. We have two things multiplied together to equal 0. So one of these two has to be 0. For x plus 16, we would subtract 16, telling us x is equal to negative 16. With our x minus 4, we would add 4. So our two solutions we get is that x is equal to negative 16 and x is equal to positive 4. Which one do we think is probably not going to work? The negative 16. Log base 4 of negative 16 plus 12. Plus log base 4 of negative 16. Well, we know this isn't going to work because that second one, that log base 4 of negative 16, simplified as it gets, have a negative inside that log. If we did simplify it all the way out before we start evaluating the logs, we'd get log base 4 of negative 4. Can't take the net log of a negative number. Same with log base 4, it's negative 16. So it doesn't work. Now our other value, when x was 4. Now for that second logarithmic expression, log base 4 of 4 is fine. Our first one, log base 4 of 4 plus 12, well 4 plus 12 is 16. These are actually the first ones today we can actually simplify without a calculator. Because log base 4 of 16, 4 to what power 16? Well, that would be 2. Log base 4 of 4, we said when the base and what's inside are the same, exactly it reduces to 1. And 2 plus 1 is 3. That's what it told us it was. X equals negative 16 would be an extraneous solution. We throw it out. So the only solution that worked was x equals 4. So again, I would check. I would not immediately throw that negative 1 out, because if it had been just x squared, we don't have an x term, there's a good chance it does work. Questions on any of this here? All right. We're going to come back to the minus ones. I want to jump to this one here. It is the last problem before the note or the homework sheet. Last one. We're able to find it. Bottom of the last page before the homework. Natural log of x plus the natural log of x minus 5. Now I want to bring attention to this, not because there's any huge differences. There's one main difference, and it comes at the very end. Because even though this is natural logs, we do have two logarithmic expressions being added together with the same base. So we can rewrite this as a single log with what's inside being multiplied together. So our natural log of x plus natural log of x minus 5 is the same as the natural log of x times x minus 5. That's not any different than what we did before. Now that we have one term or one expression on either side, we're going to put both sides to the base of the log. And our base of this log is e. So we're going to put both sides to the base of e. Again, has not changed from the previous ones. We're doing the exact same steps as we're doing. E to the natural log, e and the natural log will simplify, leaving us with x times x minus 5. The right-hand side does not simplify. leaving us with e to the third. Again, no difference between the last three that we did. Now we do need to find the product on the left-hand side. We're going to distribute this here. X times x is x squared. X times negative 5 is negative 5x. Now we need to figure out what e to the third is. So I can grab the calculator, second ln 3. It tells me it's 20.08553692. Again, e is an irrational number. So e to the third power is still an irrational number. So some, I would disagree with them, but some would say we would approximate, we would round it. I would not want to round here. We're not anywhere closer. We're getting closer to finishing the problem, but we want to wait to the very end to round or approximate. If we round too early, the difference in what the answer is gets bigger and bigger. Questions on this here? We have an x squared term. We still have a middle term. So we need to get this quadratic equation equal to 0. So to do that, I'm going to subtract e to the third from both sides. E to the third minus e to the third is 0. Telling us that we have x squared minus 5x minus e to the third is equal to 0. This is where the big difference comes in, is because I cannot factor this. As much as I want to, I cannot factor it. So what we're going to have to do is we're going to have to use the quadratic formula. And this here attaches to our ax squared plus bx plus c. And we just need to plug the values of a, b, and c in and simplify down. A is the number in front of x squared, and that number is 1. Yes? B is the number in front of x, so it would be negative 5. C is our number without x, and it would be what? Negative e to the third. Even though e is a rational number, it looks like a variable, it is still a number. It has a value. We found it a minute ago. So if we plug this into the quadratic formula, so the first thing we'd start off with is negative b. Well, that'd be negative 5. Plus or minus the square root of b squared, negative 5 squared, minus 4 times a, so we have negative 4 times 1 times c, and c is negative e to the third, all over 2 times a. So once we finish plugging everything in, we get negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative e to the third, all over 2 times 1. Now a few spots that, especially we've done this before, will simplify nicely. Negative 5 is 5. On bottom, 2 times 1 is 2. Now, one thing that's going to be a little different is at this point, I'm not going to plug everything inside this radical into the calculator because e to the third is irrational, so it's going to give me a decimal approximation, which then we're going to have to take the square root of, which is going to be another decimal approximation of that approximation. So for me to get the answer and get as close as I possibly can, we're going to simplify it by hand as far as we can. Really, that's not going to be a whole lot. Negative 5 squared, 5 times 5 is 25. Negative 5 times negative 5 is still just 25. Now, negative 4 times 1 times negative e to the third. Well, wait, I have a negative times a positive times a negative. Negative times a positive is negative, times that other negative makes it plus. So we took care of the signs. Now let's actually see our product. We have 4 times 1, which is 4, and 4 times e to the third as well. 4e to the third. So the exact solutions that we get from this here is x is equal to 5 plus or minus the square root of 25 plus 4e to the third all over 2. And if we were just solving quadratics, we would circle this and be done. But this here has to go back into a logarithm. If one of these two values makes the expression inside that logarithm be negative, we have to throw it out. And we do have 2 solutions here. Because what we have is x is equal to 5 plus the square root of 25 plus 4e to the 9th, or not 9th, e to the third, all over 2. And our other one is 5 minus square root of 25 plus 4e to the third over 2. Exactly. Now I would plug it into the calculator and see what I get. 7.632. So x is approximately 7.632. If this works in the original problem, I will take it, or 5 plus the square root of 25 plus 4e to the 9th all over 2. I will take it in either one of those forms. Now we have to plug the other one in also. 5 minus square root of 25 plus 4e to the third all over 2. And it tells me it's negative 2.632. Yeah. I would agree. There's a good chance we're throwing that one out. And the reason I say that is not because the x is negative, but because our original expression was the natural log of x plus the natural log of x minus 5. Because if we use this negative 2.632, that first logarithmic expression, we're taking the natural log of a negative number. It does not work. We have to throw it out. Even if we simplified the other side, or the other natural log, it would be negative 7.632. 2 negative numbers does not work. Now 7.632 plus natural log of 7.632 minus 5. And we should expect this to be what? 3. Yes? Are we going to get exactly 3? No. And the reason we're not getting exactly 3 is because we had to approximate, we had to round this answer to 3 decimal places. I don't know if this is a scientific way to do it, but again, we rounded to 3. This is the approximate. We've got more than 3 zeros. I'd say it's close enough. That is the correct answer. Questions on this here? And this also points to the fact that just because A, B, and C are not integer numbers doesn't mean the quadratic formula doesn't work. We can actually do this with A, B, and C being logarithmic expressions and still get an answer. But we're not going to worry about subtraction. It doesn't come up. I threw it in there as a nice little tidbit so we can see it, but we're about out of time. But the assignment is 5 problems, 33 through 37. 33, 34, 35, and 36, you will get one solution that works. You're most likely going to get one extraneous solution as well. 37 will have two solutions, two values of x that work.